Hey, I'm Milan, the lead product developer at Molecular Quantum Solutions. So today we're going to walk through a workflow with the Cebule engine for implicit solvation. What we're first going to do is run a geometry optimization of the ethanol molecule. We're then going to take this result and use it in a COSMO DFT simulation to simulate the solvation effects from a water solvent. And finally, we're going to put this COSMO result into a sigma profiles calculation to get a compact descriptor. So let's get started. To see, first of all, this is the dashboard of Cebule with the previous tasks that have been run. We can click Create Task to go ahead and make our geometry optimization task. So let's select for task type, geometry optimization. And there are two ways to run this task. The first way is if you want to just enter the smiles of your molecules. And the second way is if you want to enter the symbols and coordinates to be an initial starting point for the geometry. Let's go ahead and do the smiles input. So we're going to do 4 cores is decent for geometry optimization and enter the smiles of ethanol. So what this task is going to do is first do a quick initial force field optimization using the MMFF94 force field, and then use those coordinates to then do a further, more intensive optimization. And here we're going to select GXDB to use the recently updated semi-empirical method by Professor Grimmy's group. So let's go ahead and hit Create Task to kick off this optimization. So once that finishes, we can scroll down and hit Preview Result. And this is going to show us the final geometry of ethanol. So let's go ahead now and run our COSMO task by hitting My Tasks and then Create Task. And then over here, we're going to select the COSMO task type. And for COSMO, it's good to use 64 cores because we're doing a DFT simulation, which is computationally intensive. There's 2 ways to run this task too. The first way is if you also want to just enter your elements and geometry to kick off the COSMO simulation. And the other way is if you want to connect a geometry optimization result. So here we're going to connect the task we just ran to optimize the geometry of ethanol. And that's going to be the initial starting point for the COSMO simulation. Here we're going to do a DFT geometry optimization using the COSMO model to simulate solvation if ethanol was in a water solvent. And there's a bunch of parameters you can change here. The default values are generally reasonable to get you started. One value you should change is the dielectric constant, and that reflects the solvent. And here 78 is what we're going to keep because we're simulating water as a solvent. But if you were using a different system, you should change this value. So let's go ahead and kick off this COSMO calculation. So once this finishes, we can again scroll down to Preview Result. And over here, we're going to see the surface charges computed by the COSMO model. So finally, let's now go back to My Tasks again and hit Create Task to do our sigma profiles calculation. So here we're going to select the sigma task type. And we can just do this with 1 core because sigma profile is a very quick calculation. So let's connect our COSMO task that we just ran to now compute some compact sigma descriptors for it. And we have 2 options here. We can use the COSMO-RS model, which will give us some sigma moment descriptors, which are very compact representation of the charge density. And the other option is the COSMO-SAC model, which is also good for solubility. So let's go ahead and do COSMO-RS and hit Create Task. So once that finishes, we can now again hit Preview Result, and it's going to show us the surface charge density as well as the sigma moments, which are those compact descriptors that you can use for ML model training as well as other applications. So now with these few steps, you're ready to run your own COSMO calculations. Definitely give it a go with your 25 minutes of free compute time on Cebule and see how this can simplify and enhance your computational workflow. Have a great day.